Alright, so here we are going to learn that basic Hello World Java application step by step, okay? And we're going to actually learn a few more concepts such as statements, blocks, Java identifiers, Java literals, variables, primitive types versus reference types, operators. So here we are actually getting exposed to Java programming syntax for the first time. So let's learn how we construct how the Hello World sample application that we have run in our previous exercise is constructed. So this is the application that we have basically blindly copied and then run it. Okay, so we are going to see each of this line, what that each line means. Okay, so let's move on. So the first line, public class hello. So every class has to start with class keyword, and then you can, and then public class. So the the public is basically access modifier, meaning basically who can access the class. Okay, so you are going to start your class with a public class, and the name of the class. Hello is the name of the class. Okay, so every class definition or declaration starts like this. So if you're trying to build the XYZ class, then you are going to start with public class XYZ, and then the curly brace starting indicates the starting block of your code. All right. So this curly brace indicates start of the code block, as I mentioned before. So in class, all the code of your Java code, all your Java code has to be part of your class. Okay, so this starting curly brace indicates you are starting your first Java code. This curly brace could be the next line or at the same line. Okay, so typically the convention is using this curly brace, starting curly brace at the same line with your class declaration. And then the next three lines is a comment. So you are going to see there are two different ways that you can add your comment. One way of adding the comment is starting with /* and end your comment with */. So everything in between will be considered as comment. So comment does not add any logic. It's a documentation. Okay, so when a file, your Java source file, is compiled into a class file or bytecode, these comments are of course removed. Okay, because comments are only useful when people are looking at the source code. Okay, now you have main method. So every Java application has to have a main method. So main method, you can think of it as a starting point of your Java application. So without the main method, Java runtime does not know where to start. Okay, so every Java application has to have main method. So main method start with a public static void. So this main method syntax has to be exactly like this. Okay, has to be public static void main, and then string array and args. Okay, so this is exactly the same format for all Java application. So we are going to learn what public static void means later on. Okay, but just to give you a sense of what that is public is what is called the access modifier, meaning who can actually access this method. Static means that this method is a static method. We're going to actually learn static versus instance method later on. Void means that this method does not return anything. And then name of the method is a main. Okay, and then string array is basically arguments. These arguments represent command line arguments that you specify. Okay, so if you don't understand the syntax of all this, what I just mentioned, don't worry about it. Okay, so just assume the main method has to be in every Java application, and the main method has to be exactly like this syntax. So this is a way that Java runtime figures out that this is a starting point of this application. Okay. All right, so that is a main method. And then you can have another comment format. So the second format of Java command is using // So the difference between these two different command formats, so the first one is using /* and then // right? In this case, it's basically anything in between will be considered as a comment. When you're using second format, which is a // that means it's a comment only for that particular line. So if you want to actually comment per line, then you are going to use a // So if you have another comment, then you have to use a // again. Okay, so // format as a comment is only for a single line, while the /* and the / is for multi-line comment. Okay, then you're going to use what is called the system.out.println, and then you specify something that you want to print out. Okay, so this command is basically, I want to print, in this case, something to print. This is an argument to print to system output device. Okay, so every Java program can use output device, input device, and error device. So typically, system out device and error device is actually display. So in this case, is the console. Okay. So again, we're gonna actually learn system.out, what this means later on in detail. Okay, when we learn IO stream, but for now you can think of system.out.println is a way of printing things out to the console. All right, and then you have to end your code block, okay, with corresponding curly brace. Okay, so this main method contains a single line code and a comment in our example, and that has to be ended with a curly brace here. And your class block also has to end with a curly brace. All right, so that hopefully gives you a sense of how this particular class is made of. Okay, so coding requirements. Every Java file has to end with a .java extension. So this is a way that compiler figures that this is a Java code. Okay, and also this is something that was asked before. A file that contains Java class code, in this case, for example, like hello class, must match the name of your public class. Okay, so if you're creating hello class, it has to be created as hello.java file. If they do not match, then it's a compile error. Okay, so it's a requirement. So this is an error condition that you might experience on and off when you are writing your Java application for the first time. The name of the file has to match with the name of your class inside that Java file. Okay, so we already talked about Java comments. So there are two different ways that you can add comments, again using these two different syntax. // is for a single line, and /* and // of course you can use for single line comment, but typically that is used for multi-line comment. Okay, so let's move on to statements and code blocks. So code block is made of set of Java statements. Okay, so each Java statement ends with a semicolon. Okay, and code block is a set of statements and has to be started with a curly brace and end with a curly brace. Okay. And white space does not matter. Compiler will in fact remove these white spaces, and then it will create the bytecode or class file. So white spaces are simply ignored. Okay. So in this case, this main method has two Java statement. Okay. The two println statement, and these two println statement construct a code block. In this case, for main method. All right, so let's move on to Java identifiers. Identifiers are names. Okay, so the definition of Java identifiers are They are tokens that represent names of variables, methods, and classes. So we haven't really learned the concept of classes, method, and variables yet, right? We'll actually learn those things later on. But for now, those variables, those methods, and those classes, they all should have names. Okay. So basically, Java identifiers has to follow some syntax. Okay. So the names must begin with either letter or underscore or $sign. Okay. In fact, you cannot start your name of your variable or name of a method or name of the class with a number. Okay. Once you start with your names with a letter or underscore and $sign, then you can have numbers. So you cannot have, when you create the hello.class, you cannot have 3 hello.java file or 3 hello.class because number cannot be the first letter. Okay. And the names are, by the way, I'm using the term names as Java identifiers are the same interchangeably. So the names of these variables, methods, and classes are case sensitive. Okay, so this capital H hello is not the same as small letter 8 hello. They are completely different names. Okay. And of course, your names cannot use a Java keyword like a class public void. These are the keywords that are reserved by Java. Okay, which means you cannot use these keywords as name of your variable, name of your method, or name of your class. All right, the concept of Java keywords. So these are the words that are reserved by Java for specific purpose. So for example, like a class keyword is reserved for Java for declaring a class. So you cannot use class keyword for your own identifiers, meaning name of variable or class or method. Okay, so the examples of Java keywords are like this. Okay, so of course you have seen class, right? Okay, and we have seen like a void. Okay, so package, private, public. So these are all keywords, and you cannot use Java keywords as part of your name. I mean, as a name of your variable or method or class. These are reserved words. Okay, so let's move on to Java literals. You can think of Java literals as constants, constant values. So literals are tokens that do not change. They are constant values. So there are different types of literals in Java. For example, integer literals, floating point literals, Boolean literals, character literals, and string literals. So let's see examples of these literals. Okay, so the special notations in using integer literals in our programs. So if you're using like a 12 or 13 or 5, that is considered as integer literal. Okay, if you want to have it as hexadecimal literal, then you can use OX or O capital X. If you want to represent it as octal, then you're going to start with O14. So if you want to just use regular integer, then you just use a number, 12, 13, 5, 4, something like that. So this is a floating point literal. So if you use 3.1416, this is a floating point literal. Okay. You can actually represent floating point literal in 2 different ways, in standard fashion, or you can use a scientific notation. So either one is fine. Boolean literals, there are only 2 values possible, true or false. Okay, so these are Boolean literal constant values that are already available, already defined in Java. So true and false, of course, they are keywords, meaning you cannot use true or false as a name of your class or name of your method and name of your variable. Character literal represent a single Unicode character. So Unicode character is basically 16-bit character. Okay, and it replaces 8-bit ASCII character set. And so Unicode allows inclusion of symbols and special characters from other languages. So pretty much all the languages humans spoke speak right now can be represented in 16-bit Unicode. Okay, character. So to use character literal, enclose a character in a single quote delimiter. So if you want to represent character A, then you want to use single quote A like this. Okay? And there are special characters such as new line character or backslash new line character. And then you want to represent it using backslash special character. So if you say single quote starting single quote backslash n, that represent new line character. Backslash r represent carriage return. Backslash b indicates backspace. String Java literals is most common Java literals, and string Java literals are represented with double quote. Okay, so you say double quote, starting double quote, and whatever string you want to represent, and then end with double quote. All right, so let's move on to variables. So variable is used to store the state of objects. So again, we haven't learned the concept of objects or classes yet. Okay, so don't worry about it if you don't understand what this first line means. Okay, so you can think of variable is basically attributes or properties inside a class. Okay, so variable has two things. It is constructed with a data type and the name. Okay, so let's see an example of that. So if you want to have grade as a property of your class, then you can say double. That is a data type. In fact, this is a primitive type, and name of variable is grade, and then you can assign the default value for that variable. There is what is called the reference type, and we'll see the difference between primitive type and reference type. If you want to use a double reference type, then you specify the data type. Again, this is called the capital D double and the name of the variable. Okay, so here, because you have not assigned anything as a default, it's going to be set as 0.0. Person is a class. So if you want to actually create a variable whose type is a person type, then you say person X. Okay, again, these are examples of data types, and we'll see what data type means later on. For now, we are mostly focused on the syntax of a program. Okay, so this is the again complete Java application. So let's see, let's dissect this application. So we define a class called the variable samples. So every class should start with public class, name of the class, and then it start with a curly brace, and then it could have a many method, and one method it should have is a main method. Okay, so it does have a main method. So main method start with a public static void main, and then it will receive arguments, okay, in a form of string array. And here we define three variables. Okay, so one is called the result, and it's a Boolean primitive type. And then we have defined, we actually defined four variables. Second variable is called the option, and it's a char character type. And then, so we actually define three variable type. Here we actually assign a value C to option, okay, variable. And here we are defining grade double variable, assigning default value of 0.0. Okay, so this is an example where we have defined three variable types. Okay. Okay, now once you have defined a variable types, then you can manipulate them. So here we are assigning value 10 to int variable type, and we declared or defined X char type, and we are assigning it, and then we can use system.out.println to print out the values. So this is the we are just displaying the value of this one. That should actually display 10, and here we are displaying this string value, and then whenever you want to concatenate the result of something else, then you're going to use a plus sign, and then value of X will be displayed. So here is going to display as the value of X equal A, which is set here. Okay, in terms of println versus println, we'll add a new line at the end of the output. Okay, so if you're using println, everything will be on a different line. If you're using print, then new line will not be added. Okay, so whatever you are going to the printout will be just concatenated at the end of the data output. All right, so let's move on to primitive type. So Java provides two different data type. One is called the primitive type, the other one is called the object type. The reason Java provides primitive data type is it actually provide a better performance. If you are doing some kind of computation, usage of primitive type will actually make your program run a bit faster. Okay, so there are the 8 primitive type like a Boolean, char, byte, short, int, long, and double, and float. Okay, all right. So these are primitive type. So what is the primitive type? Basically, is actually assigned fixed size in memory. Okay, so it actually takes a lot less memory space, and because of that, Java can actually compute faster if you are actually using primitive type for computation related logic. Okay, so primitive data type is non-object values, so they are not object. Okay, and again, it's provided in Java is provided for higher performance. So other programming language, for example, like Rails Ruby. Okay, they don't actually provide primitive type. Everything is object type. Okay, it has a pros and cons. Okay, so primitive data type, in this case logical Boolean primitive type. So the way that you are going to specify Boolean primitive type using low letter B, Boolean, and the result, and true. So we are assigning true as a value to result Boolean data type, Boolean primitive data type. Okay, so it could be either true or false. Okay, so in this case, the example declares a variable named result as a Boolean type and assigns a value of true to it. Textual, in this case, char data type. So here you can assign, this is the actual, the char literal, right? It represents A and it represents a tab, okay? So to represent a single special character like a single quote, a double quote, then you have to actually escape it with a backslash. So in this case, if you want to represent a single quote, then you have to represent with backslash. If you don't actually have a double quote, and then you have to represent with a backslash. Otherwise, it's going to be actually considered as a starting single quote and ending single quote or double quote. The byte. So here, 2 or 077 or 0xBAA. So these are all possible literal values. Okay. Integral types have a default data type. You can define the long value by appending the letter L or L. So in this case, if you want to actually have the value as long, then you can say 10L or 10 capital L or 10 lowercase l. Okay, so this is the range. So the size that is being assigned to this primitive data type, byte, is consuming just 8 bits. Short is consuming 16 bits. For int is going to consuming 32 bits, and long is going to consume 64 bits. And based on this size, the number of bits, of course, the range is going to be different. Floating point. So these are the examples of floating point. 3.14. I mean, you can actually represent in scientific format like this. Okay. So again, a floating point is another primitive data type. Okay. All right. So float and double. So float is taking 4 bytes and double is taking 8 bytes. Okay. So they have a corresponding range. All right, so we talk about the primitive type and the object type or reference type. When I say reference type, it means object type. Okay, so I'm using two different terms interchangeably: reference type or the object type. They are the same thing. Okay, as opposed to primitive type. So primitive type variables is a variables with a primitive data type such as int or long. So it stores data in actual memory location where variable is. So it actually consumes particular size like a 4 bytes or 8 bytes or 2 bytes or 1 byte. Okay. Reference variable, however, is variables that store a memory address of an object. So there is an object, and then this reference variable will actually is actually containing pointer to that object. Okay, so the difference in terms of how primitive type variables and reference type variables are stored underneath is that primitive type, they actually contain the values. Okay, for reference type, it actually contains a pointer to an object instance. Okay, so object instance will consume some memory, and the reference variable or the object variable is not containing the value of it because there is no value. It's actually containing the pointer to the memory address of the object instance. Okay, so we'll see that example using a picture in a few minutes. So when you declare a variable of certain class, so class means object type, you are actually declaring a reference variable to that object with that certain class. Okay, so again, if you don't understand the class and object for now, don't worry about it. Okay, yeah. So this is an example. So this is so basically your data is going to be represented in memory. Okay, so these are the variable names. Okay, all right. So if you happen to have an object instance, like a string object instance is hello, okay, your name variable will actually point here. So this name is a reference variable or non-primitive variable or object variable. Those are all same things. This num is actually primitive variable that is containing the actual value. So if num primitive value, primitive type, let's say it's int num, it actually contains a value of 10. However, if name is reference type, okay, of string object, it actually points to the address of this hello object instance. Okay, so this is something that you don't really have to worry about. I mean, this is basically to understand what's being done underneath. It doesn't really affect how you program. You really don't have to actually understand what is being done underneath. This is all handled by Java. Okay, so operators. So there are multiple types of operators: arithmetic operators, relational operators, logical operators, conditional operators. So, obviously arithmetic operators. So let's actually kind of see the examples. Arithmetic operators are basically for adding, multiplying, dividing, and modular fashion and subtract. Okay, and you can there are increment and decrement operators, plus plus and minus minus. Okay, it's basically adding by 1 or subtracting by 1. So in this example, I am adding a value of count by 1, and then I am replacing current value of count. So basically this statement is incrementing count by 1, and this is the same as this. So this notation is simpler format than this. Okay. All right. Increment and decrement operators can be placed before and after an operand. Okay, so what it means is that you can have this plus plus sign before j or after j, and there is actually some implication. If you have a plus plus j and plus plus before a variable, that means it will get incremented first before that is used for computation. So in this case, we have I equals 10 set with the value 10. J is assigned value of 3, K is assigned value of 0. So in this case, plus plus J, plus plus is before J. Okay, so in this case, J will be incremented by 1 first. So J is going to be 4, and then it will be used for computation. So 4 plus I, which is 10, so it will actually result, K is going to be resulted in 14. However, if you have plus plus after j, that means this computation will be done first and then j will be incremented. So here j is going to be used for computation first. So j is 3, right? So 3 plus I, which is 10. So 13 is going to be assigned to k. So k is going to be 13, and then j will be incremented by 1. So j becomes 4. Okay? So depending on where you have this plus plus before or after a variable, the implication is different. All right, so that is arithmetic operators. Now, relational operators are basically compare two values and determines the relationship between those two values. And result is going to be true or false. Okay, so here we are going to see whether the first one is greater than this, and the result is going to be the true or false. Okay, so this is greater than and equal, greater than and or equal, and this is less than, and this is less than and equal. This is equal, and this is not equal. Logical operators have one or two Boolean operands that yield a Boolean result. So here, this is logical AND. Okay, and this is a Boolean logical AND. So we'll actually see the difference of these two later on. And then we have a logical OR, and then we have a Boolean logical inclusive OR, and this is exclusive OR, and this is logical NOT. Okay, so we'll see examples of this one later on, and then I'll explain the difference between this ampersand, double ampersand, and single ampersand. For now, just think of these two as like this is related for AND, this is related for the OR, and this is not. Okay, so so basically, if the first operand is true and the second operand is true, then it will result in true. Okay, and if any of those is false, then it will result in false, and of course, both of them are false, it should result in false. And or is actually the difference, right? Okay, so here you go. The basic difference between ampersand and single ampersand operators is support the short circuit evaluations or partial evaluations, while this one does not. So given the expression of expression 1 and expression 2, it will actually evaluate the expression first and immediately return the false value if it is false, and then the if expression 1 is false, the operator never evaluates the expression 2 because it will actually, return false already. If it is true, then it will actually, evaluate expression 2 as well. And if expression 2 results in false, then the whole thing will be false. Okay. On the other hand, single ampersand operator always evaluates both expression 1 and expression 2 before returning an answer. So, basically ampersand, double ampersand is actually providing sometimes more efficient result, because if it is false, it will return right away. Okay, so this is this is OR case. Okay, and the same thing. This is the basically exclusive OR. Okay, this is the result. I'm going to just kind of move for the a bit faster because this is kind of obvious things, not much related to Java. I mean, basically Java provides these logical operators so that you can use these logical operators to combine things, okay, for logical operations. Okay, so this one, logical operators, conditional operator. So here, basically when you are seeing this one, expression 1, this will be evaluated first. This expression will be evaluated first. And if it is true, then it will return expression 2. If it is false, then it will result the expression 3. Okay? So that's basically what it does. And we'll see examples of this one in the hands-on lab. Okay? Yeah, so this is an example. So here, we want to return the status as a true or false, right? So here what we can do is we are going to see whether the value of grade, which is set as 80, is greater than 60, greater than and equal to 60, and obviously this is greater than 60, so it will return passed. Okay, if you set the value like a 40, then it will result false, fail. Okay, so if it is true, so this is going to be evaluated, and the evaluation will result true or false, and based on true or false, either this one or this one will be returned. So this is basically that operation here. Okay, so the depending on the expression returns true or false, a different result will be returned. Operator precedence, yeah, this is not that much different from the any other programming language. Okay, so here the basically precedence wise, this will be done first, and then this will be done next, and then addition or subtraction will be done next. All right, so here we actually do a lot of presentation. So let's actually take a look at the hands-on lab. So here we haven't done the exercise yet. We're going to actually do the whole exercise in a single shot. Okay, so Java programs here. So exercise 1, you are going to declare, initialize, and print variables. Okay, so here we are going to use a NetBeans IDE. So you are going to build brand new Java application as we have done in previous exercise. And here we are going to name the project as my output variable project. And then you're going to name your main class as output variable. And then you are going to add this 12 or 13 lines of code. So here we are basically initializing a value primitive type with the value 10. Here we are defining character char primitive type and then assign the value. And then we are assigning 11 to double primitive type, and then we are just displaying it. Okay. So and then you build and run the application. Okay. And we are going to actually do the same thing using Java command. Okay, so feel free to skip this one if you want. If you are comfortable with building things in command line. Okay, so skip 1.2. Okay, and then exercise 2 is conditional operators. So by the way, the sample applications are already provided. So if you do not want to write the code, you can just open the project. So you can go to open the project, and you go to the sample application. So in my case, the lab is in Java SE. And the hands-on lab is Java SE _ programmatic basics. Okay, so on the here you have sample NetBeans. So I'm gonna just open this project, and I'm gonna just run it. So here output variable project. So that's the first project. I'm gonna just run it, and you're going to see the result. So basically it compiles it and run the application. Okay, so this is what you are going to see as a result. Okay, so if you see the code, so these are the code that you actually copied from the documentation. So if you do not want to write the code, you can just open this project. But today, at least the first couple of the hands-on lab, I am going to actually recommend you to actually write this code the line by line on using your hand. Okay, so this is a way that you are going to actually write your Java code. So instead of actually copying the code, you can just copy the portion of it and then write the rest of it. Using your type like this. Okay. This is a way that you get the hang of how you actually write your Java code. Okay. The exercise 2 is a conditional parameter. So here we are basically using the same code that we have seen. So by the way, so whenever you are actually doing hands-on lab, I recommend you actually to change the code and see how things work. The only way that you are going to get the hang of programming is actually doing it. And by doing it, I also actually recommend you actually change things. Don't be afraid of making mistakes. Okay, change things and why something is failing and why something is working, and this is the way that you're going to actually learn programming. Okay, so this is the conditional operator, and exercise 3 is the computing average numbers. So let's take a look at the code. So here we define 3 number 1, number 2, and number 3, and then we add those 3 numbers, and then we divide by 3, and we compute the average number, and then we just display those numbers and average number. Okay. All right. And exercise 4 is finding greatest number. So here, if you look at the code, we have 3 numbers, and we have a max number set with a 0. So this is not really required because it's automatically set with a 0 as a default. And then we basically determines which one is the highest. Okay, so we use a very basic logic here. We just compare number 1 and number 2 and find out which one is bigger. And then we compare that number with the number 3, and then we find out which one is bigger. Okay, so this logic is only possible when we have only small number of variables here. Okay. Okay, so I'm going to give you 15 minutes, and I'm gonna give you 10. I'm gonna give you just 12 minutes. So this is relatively straightforward. So I'm gonna give you just 12 minutes, and before lunchtime we have a 10 minutes presentation. Okay, so 12 minutes. So let me make sure that we